For this series in Spacecraft Guide, we are going to focus on the Space Shuttle. We're going to concentrate on the flight instruments to teach you how the astronauts flew the Space Shuttle in flight and in orbit. Stay to the end to see how you can get this manual that Neil Armstrong used to learn about his spacecraft to land on the moon, and this section for a deeply discounted price. In this issue of Spacecraft Guide, we are going to continue to teach you how to fly the space shuttle by going through the flight instruments, and those instruments are located on the primary flight display. And when we go into the primary flight display, we are going to focus on this part of the display right here, and that is the digital attitude display. And when you click on it, it takes you to the digital attitude display page. And what the digital display here is a digital readout of the ADI, this ball right here, in the upper right up here, showing the current roll, pitch, and yaw attitude in degrees relative to the given reference. Now, reference means what are we using to lock onto to get this orientation. Now, this reference could be the Earth, a satellite, or the International Space Station. So you put into whatever you want up here, and that will lock on and give you a reference of how you are for either docking, if it's a satellite or the International Space Station, or to the body itself. Like here, it's the Earth for the space shuttle. In a spacecraft, it could be the moon, it could be Mars. It just depends on what your reference is. Now, the R is for roll. That's the current position of the spacecraft in the X-axis. So roll is X. P, pitch, which is up and down, is the current position of the spacecraft in the Y-axis, and Y is the yaw, or the current position in the Z-axis. I know we have Y here twice, so you have to be careful with that. But that is explaining how this all works. So if we look here, we have roll of 180 degrees. So 0 degrees would be straight up and down as relevant. And as you can see, that means that the roll is 180 degrees, we're upside down. And another hint for that is all the numbers are upside down. So that is the roll, that's R. P is the pitch, now that's up and down. And we see that is 16 degrees of pitch. Well, 16 degrees, since our roll is 180 degrees, the pitch here is 16 plus 16, or actually is 16. If, again, if it was up here to be 16 degrees pitch down, that would actually be 360 minus 16. So that's how you're getting those numbers. So this is 16 degrees plus up, that's the horizon, we're upside down, so we're 16 degrees up, and the yaw is 0. Okay, you can see we're right on that center line. We haven't gone left or right, so that is what it is explaining. So if we go into general, we'll see this is the GNC software commands that affect the vehicle control and provide sensor data needed to compute these commands. And we go in here, in the navigation and control software command in the GNC system affects the vehicle control to provide sensor and controller data needed to compute these commands. They're in 3 steps. The guidance software source computes either the location required to satisfy the mission requirements. Navigation then tracks the vehicle's actual location, and flight control then transports the orbital to the required location. So all of those locations, that has to do with the reference of where we are, where it is. And that is what those numbers are showing. It's like, okay, what is in that reference that we're seeing, and how do we get to where we want to go. Now, for our Patreon subscribers, our paying subscribers, and our free subscribers, that means for no money, you can follow me and we'll go into the schematics with me. So just log on or just sign up for free on my Patreon page. The link will be down below. And when you do, and we click on schematics, we go into the schematics. Now this is again for the lunar module. I'm using this schematic as a reference towards the shuttle because there are none of the schematics that are this detailed. So here we have the ADI, or here they call it the FDAI, Flight Director Attitude Indicator. And you can see that we had our pitch steering errors, our rates on this side. Now we're going to go this to the total altitude. Now, as we see this total altitude, that is coming in from the GASTA, which that acronym stands for Gimbal Angle Sequence Transformation Assembly. So this is the box that gets all of the information. And where does that get that information from to send the data over to here? We get it from the gimbal angles that come in, and in this case, from the attitude monitor, it is in PGNS, which is Primary Guidance Navigation System. You can see that's the up here. That comes from the gimbal angles, which comes from the IMU. So again, the IMU is all the angles, and the gimbals are measuring those angles electronically and sending the electronic data up to here through the primary guidance navigation system, and that system basically right in here. This little gap here is where they put it in. That is going to determine where you are in space, and it's going to take those angles and bring it up to this box. Now this box takes those angles, interprets them, and puts them into electronic pulses, which go to the FDI, and that is what tells you exactly, or what tells the FDAI, or for the shuttle, the ADI, the attitude ADI, and it gives us the pitch, roll, and yaw. And those angles that it gives are the ones that are displayed right up here in this corner that comes from the IMU. Now, for our paying subscribers, and what that are my Patreon subscribers that pay the minimum, which is $4 a month. That's right. For a cup of coffee, you could be looking into the in-depth explanations of what we go over of this device, and it's only for a cup of coffee. You get a whole month. So it's really a good investment, and it helps us to give you great detailed information like this. So if you are a paying subscriber and you click on schematics here, for all of my YouTube subscribers, I have a special for you. I just launched my Apollo Operations Handbook Block 2 spacecraft, which is the Apollo spacecraft that went to the moon, the docking and transfer section. So it is on special right now. We saw it in the beginning for $4.99. Right now it's $2.99. That price is going to go up in a couple weeks. So if you would like this book at almost half price, $2.99 as opposed to $4.99, then this is now is the time to get it. And basically what I did is I took the NASA Apollo Operations Handbook that was made in the late 1960s, early 1970s. This is the book that Neil Armstrong used, and I put that into an electronic format with hyperlinked content, so you can go to all the pages, and you can also take a look at a sample of it, and we click there. then you can go down and see on the index, I have all the sections for docking and transfer here. And whoop, let's go back and read a sample. And the other thing I have also is not only do I have hyperlink to the sections, but inside the manual here, when it goes to a reference like a diagram, you'll be able to click on it. But as you can see, the only things are in blue here are what you can see. So the lunar module removal diagram, that is here, and you will be able, so if it's there, it'll click and goes into it. That's how it works within the manual. So the words inside are actually hyperlinked too. So if you want this again, it's $2.99. It only will be for a limited time, a couple of weeks, and then I will bring it back to its original price. It'll be going up to the new price in a couple of weeks. So you, since you watch this, you will be able to get this at a discount. And I hope you enjoy it and let me know what you think.